Recall what the IPCC said in their very professional promotional video.
Climate models play an absolutely crucial role in this assessment report. They are the only tools that allow us to say something quantitative about the future. Historically, climate prediction has started with predicting weather, the atmosphere, then we included the ocean, and now we're at the point where we include every component in the Earth system, including the carbon cycle and the chemistry. So that allows us to have a really comprehensive view of all the relevant processes for future climate change.
The first takeaway from this testimony is the IPCC's admission that climate models play an absolutely crucial role in the assessment report. In other words, if we discredit the climate models, the case against CO2 is severely damaged, if not destroyed, so we are going after them. Next, the young climate modeler says that the models incorporate every component in the Earth system and all relevant processes of future climate. They allow us to say something quantitative about the future. In other words, the modelers claim that their mastery over the physical laws at work in the climate system enables them to predict future climate, or at least that is the impression they try to create in their promotional video. The Working Group 1 chapter on climate models from the latest IPCC report is a little more explicit. Climate models are the primary tools available for investigating the response of the climate system to various forcings, for making climate predictions on seasonal to decadal timescales, and for making projections of future climate over the coming century and beyond. Here, the IPCC claims the ability to make climate predictions, at least on seasonal to decadal timescales. Over the coming century and beyond, it makes projections of future climate. But whether they use the words predictions or projections, they still claim the ability to tell us what the climate future will be. This we will refute. In order to better dismantle the claims made about the climate models, let's first get a general understanding of what they do. For a good introduction, we refer you to Dr. Roy Spencer. In a nutshell, a climate model is a massive and extremely complex computer program comprised mostly of mathematical equations. These equations try to simulate the physical forces, including human CO2 emissions, thought to be at play in the climate system. The calculations are made at individual grid points on a three-dimensional grid covering the Earth. This involves millions upon millions of calculations, which surely requires tremendous computing power. To see how a climate model simulation evolves over time, a YouTube video put out by NCAR is shown here. Central to understanding climate models is the concept of energy balance, which Dr. Spencer explains in his article. Basically, the models attempt to show what happens to the climate when the energy balance is disturbed by human activities, namely human CO2 emissions. While these computer models are technological marvels, they suffer from inherent limitations and defects, which make it impossible for them to predict future climate. In this regard, we offer a damning admission from the IPCC itself. The first assessment report states, "The climate system is a coupled, non-linear, chaotic system, and therefore the long-term prediction of future climate states is not possible." The situation hasn't changed since the writing of that report. This might give us a clue why so many meteorologists are skeptical about the CO2 theory of climate change as interpreted by complex climate models. What do meteorologists do every day but try and make predictions about weather based on computer models? And everyone knows that the accuracy of such forecasts degrades rapidly over time, such that they become highly unreliable after a week or so. And so they quite naturally wonder why so many climate scientists think they can reliably predict the climate 10, 50, or even 100 years from now. The reason for the inherent inability of computer models to predict is actually well understood and has been since the 1970s. It has to do with chaos theory. One of the main contributors to modern chaos theory was the mathematician and meteorologist Edward Lorenz from MIT. His story is very engagingly told in James Gleick's book Chaos. In 1961, Lorenz was running a very simple weather model on an ancient computer called a Royal McBee, described as a thicket of wiring and vacuum tubes. Even back then, computers held great promise for meteorologists such as Lorenz, Gleick explains. Quote, "Only a computer could cash in on the Newtonian promise that the world unfolded along a deterministic path, rule-bound like the planets, predictable like the eclipses and tides. In theory, a computer could let meteorologists do what astronomers had been able to do with pencil and slide rule, reckon the future of their universe from its initial conditions. But one day Lorenz, while running a simulation, decided to examine a sequence at greater length. So he halted the program, and rather than starting the whole run over from the beginning, started at the point where he had halted the run. To continue the run, he entered the last numbers from his printout, which rounded the numbers to 3 decimal places, while the computer stored the numbers to 6. When the run resumed, Lorenz's simulated weather started behaving erratically, chaotically. At first he thought one of his vacuum tubes went bad, but he eventually discovered that the slight change in the initial conditions, the rounding error, was the cause. Slight input changes didn't just cause slight changes in the output. They caused the output to behave unpredictably and chaotically. Gleick says, quote, "That first day, Lorenz decided that long-range weather forecasting must be doomed. No matter how powerful computers become or how realistic we make our computer models, we can never match the actual initial conditions." Lorenz published his revolutionary results in the Journal of the Atmospheric Sciences and became one of the founding fathers of chaos theory. The more recent work of Hendrik Tennekes further defined the limits of forecasting. Lawrence Solomon, in his book The Deniers, explains, as early as the 1980s, Tennekes was challenging the models that climate scientists were constructing, saying models could never replicate the complexity of the real world. He wrote, "The goal of science is prediction, but we stand in front of the limits of predictability." He argued that modern theory unequivocally predicts that no amount of improvement in the quality of the observation network or in the power of computers will improve the average useful forecast range by more than a few days. Subsequent research, Solomon reports, vindicates this. Now, climate modelers will be quick to propose ensemble forecasting and multi-model forecasting as ways to extend forecasting far into the future, but Tennekes dismisses such attempts as, quote, "a poor man's version of producing a guess at the probability density function of a deterministic forecast," close quote. We think he means they are still just guessing, and that these methods do not permit them to assign any kind of probability to their so-called forecasts. Another perspective on the inherent limitations of computer models comes from mathematician Peter Landesman, who is quoted in Robert Carter's book Climate, the Counter-Consensus. Landesman says, "No simplification of the climate model equations can accurately predict the properties of the solutions of the differential equations. The solutions are often unstable. This means that a small variation in initial conditions will lead to large variations sometime later. This property makes it impossible to compute solutions over long time periods. As an expert in the solutions of nonlinear differential equations, I can attest to the fact that the more than 24 nonlinear differential equations in weather models are too difficult for humans to have any idea how to solve accurately. No approximation over long time periods has any chance of accurately predicting global warming." We admit that computer models are helpful in learning about how the climate system works. However, their value is only that. They cannot be used to predict or forecast future climate. In support, we offer concurring opinions from IPCC champion Naomi Oreskes and also Dr. Kevin Trenberth, described by Professor Bob Carter as one of the advisory high priests of the IPCC. Trenberth admitted in the climate change blog of the journal Nature that the IPCC models do not and cannot predict future climate. He said, "In fact, there are no predictions by the IPCC at all, and never have been. The IPCC instead proffers what-if projections of future climate that correspond to certain emission scenarios." And Robert Carter emphasizes that projections are not predictions or forecasts. Projections have no demonstrated forecast skill and are merely selected outputs from the innumerable alternative climate futures that might or might not eventuate. But proponents of climate models are steadfast in their faith that the models are a predictive tool, just like the models used to forecast weather on which the climate models are based. If we can be reasonably successful in forecasting weather, why can't we forecast climate, they ask. Well, since they ask, here are some more reasons why they can't. According to Robert Carter, there is no theory of climate, in the sense that there is a theory of gravitation or general relativity. Therefore, no theoretical computer model constructed from first physical principles, including the climate models that are employed by the IPCC, can accurately predict global, let alone regional climate. Despite their complexity and sophistication, models contain a lot of guesswork or fudge factors. Robert Carter explains that all climate models contain simplifications of physical processes which are too complex to model. These are called parameterizations. For example, nearly all models contain parameterizations for atmospheric convection, cloud cover, and so on. These simplifications amount to educated guesses as to how these world processes work, and thus the uncertainty regarding them is high. The fact that many physical processes have to be simplified also undermines the claim that the models fully capture and implement the actual physical processes at play in the climate system. Applied mathematician Christopher Essex explains, "The very best efforts with the very best equipment cannot constitute a full treatment of the known physics because it would simply be too slow, even if it could be formulated. Therefore, In order to increase computational speed to a manageable level, models do not use all the basic physics in full detail. This is not simply a matter of efficiency, but one of necessity. Thus, to accomplish anything at all, a kind of pseudophysics is used in place of some of the actual basic physics. We will use the term pseudophysics in contrast to the jargon of the AR4, which uses the term perturbed physics. While their technical jargon may not be confusing or misleading to specialists, it would be for non-specialists. It is clear there is only one true physics, and anything perturbed from it is not actually physics at all. The term pseudophysics is more accurate, even if it is not the common jargon. Then there is the Kelvin fallacy. Bob Carter writes, "Because they presume that the physics of the climate system is fully understood, the models conform to the Kelvin fallacy, i.e., they presume that there are no unknown unknowns. But climate is far from being fully understood. We have just seen above that the effect of clouds is one poorly constrained parameter. Climate sensitivity to increased carbon dioxide in the atmosphere is another, and there are many more." In other words, the models do not begin to master all the relevant processes for future climate. They don't get natural cycles such as the Pacific Decadal Oscillation right, not to mention clouds. They also don't incorporate the latest research on the influence of the sun and cosmic rays. Famous physicist Freeman Dyson sums it up this way: "The climate models do not begin to describe the real world we live in." Because the models inevitably use pseudophysics or fudge factors and don't even begin to master all the physical processes relevant to climate, they cannot in any way be considered valid. In other words, they do not replicate reality, the climate system as it is. But IPCC apologists will be quick to object to our dismissal of model validity. They claim that the models have been validated in one very important respect. The models can't account for the recent warming without CO2. What they're getting at is this: when historical data are used as an input, the models supposedly can hindcast global temperature and other phenomena. When the increased CO2 is taken out of the equation, the model's output doesn't match the historical record. This, the IPCC asserts, is not only evidence of the validity of the CO2 theory, which is built into the models, but also proof that the models are valid and useful for predicting the future. But model hindcasts prove nothing. Robert Carter explains, "Conversely, model hindcasts that match an historic temperature curve are an exercise in curve fitting." In other words, knowing what they're trying to replicate, the modelers are just tweaking the parameters until it matches the historical record. And what if the temperature record itself is revised, which happens from time to time? Carter caustically observes that there will be a scurrying among the IPCC modeling teams to provide new outputs that mimic the new curve. "We was wrong before," they will say, "but trust us, we've got it right this time." But models can be useful, even if not perfectly valid, provided their predictions consistently come true. But here the models fail spectacularly. Please consider the following graph from Dr. Roy Spencer from the University of Alabama, Huntsville. According to Dr. Spencer, the climate models that governments base policy decisions on have failed miserably. His graph compares the predictions of 90 climate computer models versus observations for global average surface temperatures through 2013. He found that more than 95% of the models have overforecast the warming trend since 1979. Whether we use their own surface temperature data set, HADCRUT-4, or our satellite data set of lower tropospheric temperatures from UAH. We could offer many more examples. I repeat, the models are miserable failures at predicting future climate. Given the limits imposed by chaos theory, their use of pseudophysics, and their failure to incorporate all relevant physical processes, that the models have lack of validity and reliability is not surprising. Another reason for such failure is that the modelers have built into their computer programs many faulty assumptions which translate into a higher sensitivity to CO2. Because the expected warming potential of CO2, considered by itself and holding all other factors constant, is rather modest, the modelers have to find ways to increase it. An example is the residence time of CO2 in the atmosphere. The longer the models have CO2 persisting in the atmosphere, the more warming the models can predict. However, the assumed residence time is not supported by the science, as we will explore more in the next segment. This high sensitivity is also based on their false knowledge about the temperature history gained from the hockey stick and other flawed studies. The IPCC also multiplies that potential by assuming that the initial warming effect of CO2 is multiplied by positive feedbacks. But Dr. Richard Lindzen says that the idea that the climate system is dominated by positive feedbacks is intuitively implausible, and the history of the Earth's climate offers some guidance on this matter. So we conclude that the virtual reality futures, as Robert Carter describes them, and the hindcasts offered by the climate models are not evidence which support the global warming hypothesis. And there is a larger philosophical objection to the misuse of climate models as well. At the heart of the whole modeling enterprise, as practiced by the IPCC, is the long discredited ideology of scientific determinism. To understand this, let's turn to Lawrence Solomon and his summary of the work of Hendrik Tennekes. Recall that Tennekes had defined the limits of weather forecasting, which is at the heart of any climate model forecast. Solomon writes, "The problem," Tennekes eventually realized through the work of the great 20th century philosopher of science Karl Popper, was a profound one. Popper had struggled against an ideology he called scientific determinism, which states that if we knew everything there was to know about the current state of the world, we could perfectly predict all its future states. Popper saw that determinism was not only false but dangerous, leading to undisciplined, arrogant, and worst of all, unfalsifiable predictions, masquerading as science. Popper's famous principle that scientific propositions must be falsifiable requires that every scientific claim include, at least implicitly, a clear notion of what evidence would be sufficient to prove that the proposition is untrue. The danger of determinism, as Popper saw it, and as Tennekes would come to understand it in the context of climate studies, is that it would lead to unfalsifiable theories that look like science but weren't. The principle that perfect knowledge would lead to perfect predictions would create an escape route for scientists who, like climate modelers sought to explain extremely complex physical systems by building ever more complicated models to approximate the systems. Of course, the information plugged into the models would never be perfect. Thus, when the model made a prediction that turned out to be false, the model itself could always be defended on the grounds that the data fed into the model itself, which is in effect the proposition or theory, would not be falsifiable because the modeler could always claim that with perfect information it would have worked. Summing up, the IPCC's climate models cannot predict future climate. We know this because of the limits imposed by chaos theory, the faulty assumptions built into the models, the sheer complexity of the climate system, and the necessity of using pseudophysics or fudge factors, the model's failure to incorporate all processes relevant to the climate system, the use of bad science such as the hockey stick to calibrate the models, the demonstrated lack of validity and reliability of the models, and admissions from within the climate science establishment itself. Finally, the output of the climate models, whether hindcasts or forecasts, cannot be considered evidence in favor of the global warming hypothesis.